Okay, so here's another theorem which has the rest of our trig functions. Of course, we've already learned the derivative of sine and the derivative of cosine. So now we have the other four trig functions. So the derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. The derivative of cosecant is negative cosecant times cotangent. So you'll just need to spend some time memorizing these. So looking at a couple of examples using these trig functions, this would actually also involve what we just finished talking about as far as rewriting any part of your function that might make your derivative easier. And the fact that I have the fraction here, yes, I can use quotient rule, but I could rewrite this as x to the negative 1. So I could take my x, of course this is understood to be to the first power, you move it to the numerator, therefore it's to the negative 1. So now the rest of this will stay like it is. So now when I take my derivative, using power rule for this first term, I'd have negative 1 times x to 1 less power. Now, the negative 10 times the cosecant, of course, that would just be a constant multiple, so that would still just be negative 10 times the derivative of cosecant. So the derivative of cosecant was negative cosecant times cotangent. Okay, so now what we need to do is just a little bit of rewriting. Of course, I need to rewrite this so I have a positive exponent. And this would end up just changing to be a plus because you got a negative 10 times a negative 1. So this would be your derivative for this particular function. Okay, next example. Alright, so I have a sum, which means I can take the derivative of this term and take the derivative of this term. So I do those two things separately. But when I take this term, that's going to require that I use product rule because this is your first function, this is your second function, because 5 theta would be one function, secant theta would have to be another function. And same thing's going to happen here. Theta is one function, that's just your variable, and then tangent theta would be another, so I'll have to use product rule on that part of this as well. So this one doesn't have anything I need to rewrite, but definitely recognizing you've got to do product rule twice. Okay, now product rule was first function times the derivative of the second. So the derivative of secant is secant times tangent plus second function times the derivative of the first. So the derivative of 5 theta would be 5. So all of this is just this first term. Okay, bring down your plus sign and now do product rule with this part. So you'll have first function times the derivative of the second. So the derivative of tangent is going to be secant squared plus second function times the derivative of the first function. So the derivative of theta is just going to be 1. So if you couldn't see that, this is the second function times the derivative of the first function. Okay, so let's just kind of rewrite this so we don't have so many parentheses to have to look at, and then we'll figure out what we can do. So I actually could just drop parentheses. All this is just being multiplied. So 5 theta times secant times tangent plus, and this part would just be 5 secant. And here I would have theta times secant squared. And of course this would just be tangent. Now when I go to look, like do I have anything in common? I don't have something that is common to all 4 terms. So that's actually your answer for this one.